Hello and welcome to my math problem solving sessions online, and here we are doing plane vector geometry exercise 28b. It's taken from the OCR student book. So I've started from question 2. The question 1 seems simple enough. The question 2, I decided to start from this. If you have any problems, you need me to do question 1, which I doubt you will say, and do question 1. So do send me an email at mathsforeveryone@outlook.com. So yeah, okay, going to question 2. Give three vectors parallel to 2 minus 3. So when we have to do parallel vectors, the way to do is to multiply it with a scalar. Okay, so when you do that, you get something like this: 2 times 2 minus 3, or you do minus 2, or you do 5, or you could do any positive or negative integer. It doesn't have to be 2, 5 and minus 2. So we can do any positive or negative integer can be multiplied as a scalar. Okay, so and you would get here, in this case I got 4 minus 6 minus 4 6 and 10 minus 15, and they are all parallel to 2 minus 3. The next question, it says you have to find the values of x, y, s and t wherever they are. So like in question A, you have a x and y, and then you have s, so and so on. So if I pick one of these, I can pick D, and what that means is this is sx 12s, and that equals 7 minus 24. So sx equals 7, 12s equals minus 24. So s equals minus 2, and if you use that value here, you will get x equals 7 or minus 2 is minus 2 times 3 is 6, 3.5. So you will get x 3.5 and s minus 2, right? So in the same way, you can do the other one. I've also done another example, and here it's this one, and so you can see, solving this, I get s equal to 4 and t equals 3. Okay, so moving on to question 4. It says in the diagram AB is 2016. Okay, so this whole vector, they have given you AB as 2016. Find AC. The ratio of AC is to CB is 1:3. Okay, so I don't know the vector AC. I don't know the vector CB. But I know the vector CB is 3 times the vector AC. So if AC equals xy, the vector CB should be equal to 3x, 3y. And AC plus CB equals AB. So if you do this, xy plus 3x, 3y equals AB, that's 2016. So what I can say is, you can form an equation. So x plus 3x equals 20 and y plus 3y equals 16, and solving, you will see what we get is x equals 5 and y equals 4. Now notice please that here we have found out CB. Okay, we have CB. We have CB. They have asked for BC. So BC equals minus CB. So that's why I did the minus. So we've done the minus here. Okay, so we get BC. So please note that. That's an important point. Okay, the next question, then 3 vectors describe how to move between the points, which are 4 vertices of a quadrilateral. What can you say about EF and HE? So EF and HG, we can see EF equals 3 minus 1 and HG equals 6 minus 2. So I can rewrite that as 2 times 3 minus 1. So EF is parallel to HG, right? That's what I can say straight away. Now there are 4 points of a quadrilateral. So if this is EF and HG, now then EH is 0 minus 1. So H is directly below E, because I'm not going left or right from E to reach H. It's directly below, just 1 minus 1, so I have to move a distance of minus 1, so this is minus 1. So EF parallel to HG. So most likely this is a trapezium, because F and G and E and H are not parallel. It's likely to be a shape like this, GF. So it's likely to be a trapezium. That's what I work out here. So you can see that what it looks like. Now one point to note is I have started E here. Now E doesn't have to be here really. E can be anywhere. E can be a point anywhere on this square, or any square grid or any grid or anywhere. So it's not about where you start from that matters, it's about how you are traveling that matters. And when you are traveling, you will always travel in this shape, because they have said that EF is 3 minus 1. So if I am E here, and if I want to go to F, I have to go 3 to the right, 1, 2, 3, and 1 down. So this will be F. So wherever I start from, 1, 2, 3, 1, this will be F. It doesn't matter. So then there's HG and EH. So another point with E is H. So from E I have to come down. This would be my H. This would be my H. Always wherever you're going. And then you have to do G. So where is G? G is connected with H, and to get to G I have to go 6 points, 6 to the right. So 1, 2, 3, 4, 5, 6, and then 2, 1, 2. So that is where G is. So G would be a point somewhere here. So this is parallel. And then if you have to join G and F. So if you have to join G and F, what will happen is, if you, so again, if you see 1, 2, 3, 4, 5, 6, 1, 2, so it'll be somewhere here, so there'll be a G. And then again, to find so the prediction is, of course, it's a trapezium, and then draw the quadrilateral to find G and F. So how would you do that? The vector, to find the vector, you have to see how you will travel to F. You have to travel 1, 2, and then so 2 up, 1, 2, 3, so we minus 3, 2. Okay, and that's what I do here. So you can see that GF is minus 3, 2. Okay, so that's question number 5 done. Now question 6 is saying ABCD is a quadrilateral. What kind of a quadrilateral is this, and how do you know that? So very simple. AB equals DC, so they are. Now for that to happen, AB, so DC could lie within AB, but this is not the case, because they have said ABCD is a quadrilateral, so ABCD are separate points, so they can't lie on AB, so it's a separate line. It's equal. Okay, so it's equal, so it means the equal in terms of size, right? And then DA equals CB, so there is a C somewhere here, DC, so this is DC. Mind you, the directions AB, DC, we can't say this cannot be C. Okay, then it would be the other way. So this is then DA equals CB, so DA would be going this way, CB would be going this way. This is a parallelogram. Okay, so that's what I think. DA is equal to CB, DA is parallel to CB, and if you were to draw it, that's what it would look like. So ABCD is a parallelogram. So this concludes this exercise. We'll be back with more and from different sections of the book and lots of other books for GCSE and A level. And so stay in tune, watch the channel. Thank you so much for your time. And if any questions, you can send me an email at mathsforeveryone@outlook.com. Thank you.